Hi, everyone. All right, so this is going to be covering 9G, which is going to cover quadratic applications. This is the first day of quadratic applications, but more specifically, this is going to cover projectile motion. So this is literally rocket science. So, well, in a sense, but it's just algebra based, but there is calculus based projectile motion, but obviously we're not going to be doing that, just algebra based. So just to kind of start off, we have the projectile motion equation, which is actually parabolic because of gravity. Gravity is going to pull items and objects to the ground, and even though we launch them upwards. So really, projectile motion follows a parabolic shape. So that's what we're going to be looking at today. So the equation here, we have h of t equals negative 16t squared plus v naught t plus s naught. So right here where we have this v sub 0, this is actually read kind of like v naught. Or over here where we have the s, this is s naught. Okay. So when I say naught, it just represents the initial. So what is it starting off with? So we're going to be looking at the initial components of this equation, which in general terms is going to be given to you. All right, so looking at kind of the different parts of the equation. So t is going to represent time. So this is going to be similar to your variable x. So instead of x, we're going to be using t since we're looking at height with respect to time. So for the very first value, we have a negative 16. So that's going to represent the pull of gravity. So we're talking about in terms of feet per second. So that's going to be negative 16 feet per second. And if we were talking about meters, it'd be negative 9.81 meters per second squared. All right. Now, keep in mind, it is negative because gravity pulls things down, not up. So all of our parabolas here are going to have a maximum. They're going to be facing downwards, and they're going to be crossing the x-axis no matter what. Because if you remember the phrase, what goes up must come down, at least in terms of physics, hopefully. All right, so V naught is going to represent your initial velocity, and S naught is going to represent your initial height. So once again, these values are going to be given to you in the problem. You're not going to have to go looking for those. In Algebra 1, I'm not going to make you solve for the height or the velocity, but if you're in like Algebra 2 or maybe even pre-cal, I would actually make you solve for the velocity or height, or even in physics. All right, so just a couple little ground rules about projectile motion. Because we are talking about application questions here, you have to include units. You have to. If you're not including units, your answer is not complete. All right, it's like saying, all right, well, it's going at 5. 5 what? 5 miles an hour, 5 kilometers an hour, 5 meters an hour. You have to include units to be more specific about your answer. So, and then this is just kind of a general rule of thumb. So if no value for the position is given, you assume the position is equal to 0. So what that means is then the position, that means it's starting on the ground. So looking at these first questions here, we're only going to be writing the equation. So we're not actually solving for anything yet. So we're using the projectile motion equation here. The only thing that you're going to have to fill in is the velocity, or the initial velocity, and the initial height. So the negative 16t squared, you leave the same. And then your t value right here, you leave the same. We're only plugging in for the initial velocity and the initial height. So for this first one, I give you an initial velocity of 30 feet per second with an initial position of 5 feet. So once again, I'm going to start with just the equation. So h of t equals negative 16t squared plus v naught t plus s naught. And S naught sounds like snot, so it happens every year. Someone's going to say snot at some point. All right, so remember, we're only going to fill in for the velocity and the height. So we are given an initial velocity of 30. So we're going to have h of t equals negative 16t squared plus 30t. And then we have an initial height of 5 feet. So just plus 5. So just the 30 and the 5, that's all you're plugging in. That's all you have to do for this problem right here. So here is your representative equation of this scenario. So looking at the second one, now I give you an initial velocity of 45 feet per second in initial position of the ground, which means if it's going to be the ground, that means your S naught, your position, is going to equal 0. And there's Snapchat. We'll turn that off. All right. So once again, using the initial or the projectile motion equation, so we're going to have the height with respect to time equals negative 16t squared plus 45t. And because our height is on the ground, it's just going to be plus 0. So in actuality, you don't need that plus 0. So your equation is simply negative 16t squared plus 45t. So just to kind of reiterate, remember, if the height is not given, you assume it is 0. All right, and last but not least here, so we're given that the initial velocity in terms of v naught is equal to 85 feet per second, and we have, that should be s naught, not h naught. That should be an s, is equal to 75 feet below sea level. So because this is below sea level, that means your s naught is going to be equal to a negative 75. So remember, we do have below sea level, so you have to keep that into account. All right, so your equation here, so h of t, we have negative 16t squared. It's going to be plus the velocity, which is 85 feet per second. And we have below sea level of 75 feet, which is going to be your position. So this is going to be your representative equation for this scenario. So far, so good, hopefully. Hopefully no one's having a breakdown yet. All right, so we're going to get into the application parts where we're actually going to be solving these. So just kind of a heads up, there's not really anything new that we're doing aside from writing the equations. Everything else, the different components in each problem, are something that we've already done. So this is really the wrap up of Unit 9, and this is kind of consolidating everything into one idea. All right, so first off, a cannonball is fired from a platform 5 feet off the ground at a velocity of 128 feet per second. So that's just the question. The rest of these are just the different parts. So as you can see here, for each of these different parts, I actually wrote down in the margins what you have to do for each of these questions. So this would be a good little reference point for whenever you're coming back to study this. All right, so for the first part, we want to write an equation that models the path of the cannonball. So as you can already see up here, we already have the initial velocity and the initial height, or the position, has already been given. All right, so we're going to do h of t, which is equal to negative 16t squared, plus an initial velocity of 128, and then with an initial height of 5. All right, so that's part 1. That's just writing the equation. All right, so now you want to do part B, which is after how many seconds will the cannonball reach its maximum height? So here's kind of a good rule of thumb for you. Anytime it's referencing, here, I'll do this off to the side over here. Anytime it's referencing time and it wants to know a specific time, we're looking for an x value. But anytime it's looking for a specific height, that's going to be looking for a y value. So if I'm asking when, that's asking for an x value. If I'm asking what's the height, I'm asking for a y value. So you have to be very strategic as to what exactly we're looking for. So after how many seconds will the cannonball reach its maximum height? So let me draw kind of a rough little estimate. Now this is just going to be, like I said, a very rough estimate. This is nothing exact. So I'm going to draw kind of the general path. So that's not right. All right. So by no means is this supposed to be like extremely accurate by any means. I'm just going to draw a general path of the cannonball. So I want to know when's the maximum height. So really what I'm looking for is I'm looking for the vertex. And I want to know, so here's my vertex, h comma k. I want to know when. So if I want to know when, I'm looking for the x value of that vertex. So this right here is really part B. So in order to find the x value, what we're going to do is find this little doohickey. So hopefully you remember what this fancy little doohickey is called. The vertical dashed line, we're going to be looking for the AOS. So we need to find the AOS. Once we find the AOS, that's going to give us that value. All right, so over here, after how many seconds, that means that we need to do our axis of symmetry. So I want to calculate the opposite of B over 2A. So kind of referencing our equation, I need to find the A, B, and C values. So I'm actually going to do that first. So our A value is -16, which is our pull of gravity. Our B value is 128, which is our initial velocity. And then your C value is your initial position, which we said was 5. So we're just taking it from the equation that was in part A. So now that I have those values, I'm actually going to plug them into their respective place in the equation. So I want the opposite of B. So I want -128 all over 2 times your A value. So we're going to have -128 over -32. And you can just plug that in, and I believe you get 4, but should I make sure? Because you know how I am. Yep. So we get 4. Now remember, you have to have units. So after how many seconds will it reach its maximum height? So at 4 seconds. So 4 seconds is going to be your answer here for this part. All right, now for the next part, we want to find what is the maximum height. Now remember, this is asking for a specific height, so we're looking for a y value. Now, if I actually want to know what that specific height is, well, that's looking at the k value of the vertex. So now, I actually want to plug in the vertex, plug in the x value of the vertex to my equation to find out what the y value of the vertex is. All right, so I'm going to plug in the AOS to find the vertex. So in order to do that, I know my vertex value is 4, so that's what I'm going to plug in. So I want to find f of 4. So when I say find f of 4, that means I'm going to plug in 4 for any t value. So -16, that's going to be 4 squared, plus 128 times 4, plus 5. All right, so this value right here, you can literally just plug it in your calculator. I'm not going to expect you to do that by hand. I don't even want to do that by hand. I probably could, but I'm not going to because I am who I am. That's definitely not right. I can't press buttons right, apparently, but it's fine. All right, so we're going to get a maximum height of 261 feet. Make sure I plug that in. Yep. So this is going to be a maximum height of 261 feet. So remember, units. All right, and for part D here, I want to find when will the cannonball hit the ground. So once again, I'm asking when. So that refers to time, which means I'm looking for an x value. So I want to find when it's going to hit the ground. So part D, is wondering this part right here. I want to know what that x value is going to be. So I'm just doing this little drawing so you guys can always refer back to it if you need to, or just to kind of give you a visual idea of what we're looking for. All right, so to find the roots, we're going to be using quadratic formula. Now keep in mind, we want to know when it's going to hit the ground. So the quadratic formula is going to give us both roots. We do not care about this root over here. That's when it launches. We want to find out when it lands. So we're always going to want the bigger root, the root that is further right. If you give us the root that's on the left side, it's not going to help us. Okay? It's going to give us like -0.0 something. It's going to be a very small value. It's going to be very close to 0. But it's also probably going to be negative. So we don't want that. We only want the one that's on the right side. We want this one right here. All right. So given this equation or the quadratic formula, now we're going to plug in the respective values. All right. So we want the opposite of b. So -128 plus or minus the square root of 128 squared minus 4 times your a value, which is gravity, times c, which is your position. All right, all over 2 times a, which is your pull of gravity. And you can literally just plug this in. It doesn't matter. So I'm just going to do it over here really quickly off to the side because of who I am as a person. Or actually here. No, let me do this on here so I can show you specifically what I'm looking for. Okay, so if I were to do this on the calculator, so once again, here's your menu. You want to go to run matrix. So press 1 or enter. All right, so I'm going to open up a fraction. So the button right above 7. So I want -128. So I want to find both of the roots. So let's say I'll do the -1 first. So open up the square root. So then 128 squared, almost pressed the wrong button, minus 4 parentheses, -16, which is your pull of gravity, then times your position, which is 5. And that's going to be all over 2 times -16. All right, so when you press enter, you're going to get 8.0388763605. Now, let's see what happens if I go back up here and I do the other root. So if I do delete and then plus, you get -0.038873605535. We don't want this one. This is like the starting point. It's where, no, we don't need this one. It doesn't even logically make sense. We can't have negative time to begin with. So this one we can just completely disregard. So we only want that one. All right, so with these projectile motion application questions, you're going to want to round to 2 decimal places to give it a good answer. So we're going to look at 8.04 seconds. 8.04 seconds. So that's when it's going to land. Now you are more than welcome to do these by hand. I don't even want to do these by hand, I'm not going to lie. So I'm not going to expect you to. No. There we go. All right, and then for this last part, we want to find at what time is the cannonball at a height of 150 feet. All right, so kind of looking here, we know our maximum height is 261. So I want to find when it's going to be at 150 feet. So what I'm doing is we're looking for these 2 specific points because I want to know what those x values are. All right, so these are parts E. So if we want to find a specific part, remember, it's going to reach a height of 150 feet at two places, when it's going up and then when it's coming back down. So we got to find both of those. So it doesn't specify which one we want, so we have to find both. All right, so what I'm going to do is I want to set the equation equal to 150, and I'm going to use the quadratic formula to actually find those solutions. All right, so what I mean by that is I'm going to do negative 16t squared plus 128t plus 5 equals 150. So this is the equation I'm solving for. So what I need to do before I can actually do quadratic formula is I have to convert this equation to standard form. So in order to do that, I need to subtract 150 on both sides. So I have negative 16t squared plus 128t minus 145 equals 0. So I have brand new a, b, and c values. Well, at least a c value. So my a value is the same at negative 16, your b value is the same at 128, but you have a different c value at negative 145. So this is the quadratic formula values that we're going to use. All right, so just as a recap, I'm going to copy quadratic formula down here, just as a reference. All right, so I'm going to plug in those values. Now remember, we want both, not just one, we want both. So negative b, so negative 128 plus or minus the square root of 128 squared minus 4 times a times your c value all over 2 times your a value. All right, so I'm going to plug this into my, what's it called? Calculator. So I'm going to get rid of this garbage because I don't need it anymore. I don't want to distract it. All right, so I'm going to open a fraction. So I'm going to do negative 128. Let's do the plus one first. So square root 128 squared minus 4 times your a value times your c value, then all over 2 times a. All right, so we have 1.366, which is going to round to 1.37. So we're looking at a win. So this is going to be in terms of seconds. So 1.37 seconds. And now we got to look for the other root. So I'm going to go back up here. I'm going to change that plus sign to a minus sign so I don't have to retype it. Dang it. If you want to retype it, you go for it. That is up to you. And then our other root is going to be 6.63391. So that's going to round to 6.63. Alrighty, let's go back to the iPad. All right, so this diagram is kind of a good representation of what we're looking for at what points, when, and whatever. So these questions in the margins, they have exactly what to do and how to do them. And then of course the questions are going to have exactly what I did. So you can use that as your reference. All right, now I'm going to go ahead and go on to the second one. So this one's going to have more questions, but I'm also going to try to do the calculator on these a little bit more, just so you guys can get an idea of how you can do these on the calculator. All right, so a catapult launches a boulder upward of 6 feet off the ground at an initial velocity of 160 feet per second. So we want to write an equation that models the path of this boulder. So first off, we need to find our initial velocity and the initial height. So we have 6 feet off the ground. So that's going to be our initial height. So this is going to be S sub naught. All right, so this is 6 feet. And we have an initial velocity of 160 feet per, so far down there. So this is going to be V naught. Actually, let's do this. Feet per second. Is it feet per second or feet per second squared? That's gonna drive me nuts. It is squared. Whoopsies. That is squared. All right, let's go back up here and fix all these. Feet. This should actually be feet per second squared. What else is there? Feet per second squared. Sorry, this is gonna bug me if I don't fix it. I think that should be good. All right. So now we want to write an equation that models the path of the boulder. So we're using our projectile motion equation, which is h of t equals negative 16t squared plus v naught t plus s naught. So remember, we're only plugging in for the velocity and for the position or the height. So our equation here is going to represent negative 16t squared with a velocity of 160 and a position or height of 6. All right, now before I go on, I do want to mention something. These are domino problems. So if you mess up part A, if you write down the wrong equation, the whole thing's going to be wrong because you're working out of the wrong equation. Now you may do all your math right, but if it's according to the wrong equation, that's not going to help you, which means you're already kind of getting everything wrong before you even have a chance to start. So double, triple, quadruple, check your equation before you even move on. All right, so now we want to find when will the boulder reach its maximum height. So this is finding your AOS, because remember this is a when, so this is your X value. So I want to find the AOS, so X equals opposite of B over 2A. So my B value, probably should find my A, B, and C values. So my A value is negative 16, B value is 160, and my C value is 6. So this is what I have to work with. So for my B value, I have negative 160 over 2 times negative 16. So when you plug this in, let's go ahead and do on the Casio. So let's get rid of this garbage. All right, so we have negative 160 all over 2 times negative 16. All right, so that's English is hard. That's going to give us 5. All right, so now let's go ahead and go back over here. If I can. Technology is hard. There we go. All right, so that's going to give us 5. But remember, you can't just say the number, you have to give units. So 5 seconds. All right. And now for part C, we want to find what's the maximum height. So that's going to be plugging in the AOS value that we just found. So I want to find h of 5. So negative 16, parentheses, 5 squared, plus 160 times 5, plus, was it 6? Yep. All right, so when I go over here, I'm going to plug it in. So negative 16, 5 squared, plus 160 times 5, and then plus 6. And that's going to give us an initial, a maximum height of 406 feet. All right. Sorry if this is a little annoying going back and forth. All right, and now I want to find when the boulder is going to hit the ground. So this is the quadratic formula. Is it still here? Booyah. All right, so using the quadratic formula, that little beast. So we're going to have negative 160 plus or minus the square root of 160 squared minus 4 times A times C all over 2 times A. All right, so remember, we want the root that is going to be further right. We don't care about the left one in this case. We want to find when it's going to hit the ground. All right, so now I'm going to plug everything in. So negative 160, do minus square root of 160 squared minus 4 parentheses negative 16 times your 8, times your C value, which is 6. No. Be gone. There we go. 2, there we go. 2 times negative 16. So we have 10.37037. So just to make sure, just to kind of show you, if I go back and I get, let's say I accidentally do addition, it's going to give you negative 0.0373604,199. We don't want that. That tells us nothing. It tells us garbage. All right, so go back up here, delete, subtract. So after 10.0373604.2 seconds is when it's going to land. All right, so round to 2, so it's going to be 10.38. 10.04. 04 seconds. All righty. Now for the part E, so we want to find how high is the boulder after 9 seconds. So this is really similar to part C, where we're just going to be plugging in a value. So over here, we're just going to be finding h of 9. That's all this is saying. So keep in mind, this is where you really want to start using logic. If it's going to land after 10 seconds, but we are looking for the height at 9 seconds, it should be generally close to 0. Because here's the thing. Let's say you're solving this question. If the maximum height is 406 feet and then you plug in 9 and you're getting 500, well, that exceeds the maximum height. So that should also be an indicator something happened. So these are really good questions to kind of use critical thinking and logic skills on. All right, so I'm going to find h of 9. So I'm just going to plug it in. So negative 16, parentheses 9 squared, plus 160 times 9. Is it plus 5? No, plus 6. I'm about to get my own question wrong. Yep. All right, so when you plug in, I'm just going to do this one off to the side. So negative 16, 9 squared, plus 160 times 9 plus 6. So this is going to give you a height of 150 feet. So relatively speaking, even though the maximum height is 406 feet, in these terms, 150 feet is pretty close to zero, considering it's going to land in about another second. So if that's any consolation or indicator of how fast this is actually going. It's actually pretty fast. All right, and then part F, wow, these just keep going. Why did I do that to myself? All right, so when will the height of the boulder reach a height of 120 feet? So this is where we're going to set your equation equal to 120 and then use the quadratic formula. All right, so here's our quadratic formula, but we're not going to use this just yet. I'll throw you over there. All right, so first we're looking at our equation, negative 16 t squared plus 160t plus 6. And we're looking to see when it's going to reach a height of 120. Why is my Apple Pencil like this? 120 feet. All right, so we got to convert this beast to standard form. So I'm going to subtract 120 first. I literally just charged this. Why is it like this? So we're going to have negative 16t squared plus 160t minus, let's see if I can do math, negative 114. That's what we're going to have for our position now. So looking at our new values, our A value is the same at negative 16. Our B value is the same for our velocity. And then our C value is what changed, which this is now our new position. All right, so now I'm going to go ahead and write in the values. Hopefully. So we have negative 160 plus or minus the square root of 160 squared minus 4 times A times our C value all over 2 times our A value. So this is what I'm going to plug into the calculator, the little handy dandy little machine. All right, so over here, I'm going to go ahead and just get rid of all this. It's just going to distract me. All right, so remember, it doesn't designate, or nope, English, rewind, buffering. It doesn't indicate which specific value we want. So what that tells us is we have to include both. So over here, I'm going to go ahead and start plugging in values. So negative 160 doesn't matter if you do plus or minus first. So I'm going to do 160 squared minus 4 times your A value times your C value all over 2 times your A value. All right, so here's our first one. So it's going to reach the height of 120 feet after 9.23 seconds. All right, and then we got to find the other one. So I'm going to go back up here and do addition instead of subtraction. So delete, addition, enter, and then we have 0.7721. All right, so I'm going to put these in order. So I'm going to do that one first. So 0.77 seconds. Oh my goodness. Okay, let's go ahead and go back over here. 0.77 seconds. Wow, my handwriting is actually terrible. And x equals 9.23 seconds. All right, that's fine. All right, so these are the two values that I'm looking for here. Oh my goodness. Why are we doing this? There we go. All right, and last but not least, how long is the boulder higher than 300 feet? So we're going to set it equal to 300, solve for the roots, and then we actually want to subtract the roots because we're looking for how long. We're looking for x values. We want to know specifically how long is it higher than that specific height. So I will say these last two are typically the more challenging questions for people. All right, so let's go ahead and start off. Quadratic formula, you go over there. Start with our equations. So we want negative 16 t squared plus 160 t plus 6 equals, was it 300? Yeah, so disclaimer, this question is going to be, it's going to be a lot, but it's just another step more than what we did in part F. Okay, so let's convert this bad boy to standard form. So subtract 300. So we're going to have negative 16t squared plus 160t minus 294 equals 0. All right, now I got to find the new a, b, and c values. So a is negative 1. Nope. A is negative 16. B is 160. And c is negative 294. All right, so now we're going to plug in these values to quadratic formula. All right, so we're going to have negative 160 plus or minus the square root of 160 squared minus 4 times a times c. All over 2 times our a value. Okie dokie. So let's go back over here. So once again, or actually, let's do this because I am lazy. All we're changing is our c value. So I'm just going to go over here and just change this little doohickey. 294. So this is with addition. So that's going to give us 2.426. we'll do 2.43. All right, now I need to find the other one. So I'm going to go back up here and change that to subtraction. And now I have 7.57. All right, so these are the two roots. So it reaches a height of 300 at 2.43 seconds going up, and then it's going to come back down and equal at 7.57 seconds. So what I want to do to those two values, I want to subtract them. So I'm going to do 7.57 minus 2.43 seconds. So it's going to be in the air higher than 300 feet for 5.14 seconds. All right. So it just kind of adds an extra step. So it's not too bad. All right, so now I'm going to do subtraction. All right, so 7.57 minus 2.43. That's going to equal 5.14 seconds. Okay, so I'm actually going to go through these problems again, but using the calculator. So I'm actually going to use the attributes and actually help you find those according to the graph. All right, so we're going to go through the same exact question. So we're going to start at part B. So we want to find, or actually here, let's do this. What I'm going to do is I'm just going to show the calculator and I'll just read off the steps as I go through them. So if you want to have that worksheet kind of pulled up with your calculator, that would work perfectly. All right, so the first thing we want to find is when will the boulder reach its maximum height? So what I'm going to do is go to menu, and I want to go to graph. I want to be able to see the path that this cannonball is going to follow. So I'm going to plug in the equation. So negative 16 x squared plus 160x plus 6. All right, so even though we're dealing with time and we should be plugging in t, if you look at your calculator here, we have x, the Greek letter theta, and we have a capital T for time. These are each common variables for math equations, angle measurements, and just overall applications in terms of time. So they all kind of represent the same idea. So even though we're looking at time, x is still the same idea. All right, so once you plug it in, we want to go to draw. And this is going to be your parabola. So I want to zoom in, so I'm going to press the plus button. So as you can see, here's your path. So I want to find the following attributes. So I want to find when it's going to reach the maximum height. So I need to find the AOS. So what I can do is I can actually just find the vertex and just look at the x value. So what I'm going to do is shift G solve, and I want the maximum value. So because I want the max, I want to press F2. So right here, x equals 5. That is your answer for part B. When does it reach the maximum height? And over here, for part C, it's asking what is the maximum height? There's your answer for that one. So this is a 2 for 1. All right, and then for part D, now it wants to know when is it going to hit the ground. So once again, I'm going to go back to Shift G solve, and I want to find the root. So I'm going to press F1. So here's the first root, the one that we can disregard, the one that we do not want. So negative 0.0373604,199. We don't need it. Get rid of it. Goodbye. This is the one we want, the one on the right, when it's going to land. All right, so this is 10.0373604.2 or 10.04. So this is the path, and eventually after 10 seconds, it's going to hit the ground. All right, now we want to find what's the height of the boulder going to be after 9 seconds. So this is where I would suggest, let's see if it does it here. Yeah, so I want to find the height after 9 seconds. So I want to calculate the y value. So after 9 seconds, there's your height, it's 150. So that also works. All right, and then we're going to use the same idea. So when will the height of the boulder reach a height of 120 feet? So I'm going to do Shift G solve, and over here I want to press F6. I want to find a specific x value. So I want to calculate an x value. So I'm going to press F2, and I want to find when it's going to reach a height of 120 feet. So after 0.77 seconds, and then use the arrow over here to toggle back and forth, and 9.23 seconds. So there's both of those right there for you. All right, and then part G, it wants to know when is it going to be higher than 300 feet. So I'm going to do the same idea. So Shift, G solve, toggle over. I want to find a specific x value. So the y value is going to be 300. So here's 2.426, and use the arrow over here to go to the other one. So 7.5739. So I want to subtract those two roots. So 7.57 minus 2.43, which is going to give you 5.14. So over here, you will actually have to go back to run matrix. So 7.57, then minus 2.43, which is 5.14. So you can do all of these literally in the calculator, but you're still going to be required to show your work on my assessments. Just know for any standardized test, for sure, use these tricks. Bye.